Anyways, what I decided that I wanted to talk about today, just for like 30 minutes or so, was integrated pest management, and maybe some soil microbiology, because I know people are very interested in that kind of thing. Mostly hey Desert Rose. I just wanted to talk to people, get some questions from people, just sort of test things out. I want to do a bunch of these, maybe weekly, maybe even multiple times a week. Really not a hard thing for me to do, to just have like 30 minutes here and there at different times and things like that. I could just start out talking about things until people start coming in, but really, I already had a plan figured out. Of course, as people come in, they're not going to have that context for what I'm talking about, so that's going to be difficult for them, but they'll figure it out, I'm sure. And I'm also going to put this up on my YouTube channel so that there's a history there, and people who didn't see the content before can see the entire thing afterwards. Right, so that makes sense. So one thing I wanted to talk about for people who are already here is sort of couch things, and let me sort of tilt this a little bit so it's more perfect. Yeah. So one thing that I wanted to talk about for people growing plants in general, with regards to integrated pest management, is how you can kind of divide up health of a plant. And health is sort of a vague thing. What do I mean by health? When I talk about a plant that's healthy, it's a plant that's growing well. I'm not talking necessarily about it having the best genes or the best immune system, and even how you would quantify that is sort of complex the further down the rabbit hole you go. But I'm just going to talk in sort of a basic level with regards to plant health, and you can kind of split up into two families of thought. The first family, or the first camp, is talking about the phylosphere. The phylosphere would be the foliar part, anything above ground, essentially. That's where a lot of people get their pests. It's where a lot of people see their pests, because we don't live underground, right? And to be fair, that's probably where the majority of pests exist for most plants. Pests and pathogens that exist on the phylosphere are things that you're all very familiar with. Powdery mildew, right? All kinds of folivars like beetles and chafers and mites, all kinds of things like that. And then underneath, in the below ground, in the rhizosphere, you have other sorts of pathogens that are also fungal or bacterial. You've got Pythium and Phytophthora, and you've got Fusarium, obviously. And then you've also got things like symphalins, and you've got root mealybugs and root aphids, and you've got all kinds of things like that. So those are sort of the two main places where you're going to fight. You're going to have two battles. You're going to have the ground, and you're going to have the subterranean level. And when it comes to dealing with pests that are below ground in the rhizosphere, that can be very difficult. Those sorts of organisms are hard to detect a lot of the time, because unless they have some sort of above ground unit, some sort of above ground form, we could say, then you're not really going to see it. So like root aphids, for example. Root aphids establish in the roots. They establish in the rhizosphere. That's where they're mostly feeding. They do feed on in the phylosphere. They do feed on the stem and the new bud material and that kind of thing. But they do mostly establish in the ground. So if you're just controlling the forms that are in the phylosphere, you're only treating the symptom. You are not actually treating the main problem. And if you don't see any forms until you see some sort of adult form that's ingressing into the top part of the soil and into the plant, until you see that, you might not even realize your plant is infested, right? Because if your organism is, let's say it takes, I don't know, let's say it takes 20 days. Let's say it takes 20 days for the root aphid or the root mealybug or whatever root organism you're talking about to develop to adult stage. Maybe you got some cuttings. Maybe you got, maybe you're gardening and you got some plant from Home Depot or something and they had a pest on it. And then that transfers over to your plant. Well, it might take, if that plant is a viable host, right, then it might take like 20 days. And by that time, you might see no damage, or you might see a little bit of wilting, you might see some stunted growth, but you probably won't see that at the beginning. And if it's a organism like root aphids or root mealybugs, they reproduce quite a bit, but it takes a little while for them to establish. So while you're not detecting them in the soil, because what are you going to do? How are you going to scout for that? You're going to have to unroot the plant, which is maybe not possible unless you're growing in a container. Maybe you can do a soil sample, but you might not come across anything if it's not on the topsoil. So you really, and a lot of the times the symptoms are non-distinctive, which is a term that means that there's nothing, there's nothing specific about the symptoms that you're seeing that would tell you, oh, that's root aphids. Right? There's no, and if you're feeding the plant really well, and it's a small population, you might not see any problems at all. So that can happen as well. So it might take quite a long time before you realize that you have an infestation. And by that time, more of your plants might be infested. Because maybe if you're not crop scouting at all, or very little, then just by statistics, you just don't notice anything. You don't notice that one root aphid or that one crawler that comes out of the soil and goes to another plant, right? So the rhizosphere what I'm trying to say is that the rhizosphere is difficult to scout. It's very difficult to consider. And that's why it's really important to be preventative. It's really important to be preventative for all kinds of controls, but it's incredibly important for things that you can't even scout for very well. And of course, depending on how you're set up, that plays a huge factor in what you can and cannot do, right? So what I've already talked about for people who are joining now is the rhizosphere versus the phyllosphere. The phyllosphere is the top part. It's the leaves, the phyllo, right? The leaves, the stem, the flower material, if it's a plant that flowers, right? And all of that kind of stuff. And then the rhizosphere just composes the root system. And in some specific cases, other stuff too, but basically just the root system. And the root system is obviously underground. We don't live underground. That's hard to scout for. So I don't want to repeat myself too much, but that's essentially what I'm talking about already. And then in the phyllosphere, you have things like mites and beetles and thrips and all kinds of other organisms that are easy to see, usually, and they're easier to crop scout for. So what is crop scouting? Well, crop scouting is the method by which you assess what's going on in your crop. And it's not just pests. That's a really important thing to articulate. You have pests, of course, and a major component or a major part of crop scouting is assessing pests. But you're also assessing your biocontrols if you're using them. But generally you're just assessing your treatments as well. You cannot know what's going on unless you have a quantified crop scouting procedure. And what I mean by that, and what I've talked about in the question and answer video that I just put up on YouTube. So my YouTube channel, where this is going to be, is called Zenthanol, and I'll upload this video to that channel. But I also had a a bunch of people put in questions for a recent question and answer video, and I put all of the questions out. It's like 30 minutes long, but I'd talk about this sort of thing too, and how important it is to crop scout effectively, and also quantify it. You can't just say, oh, this looks good, this looks better, because what is better? You have to have context. Cloudy Brains is asking, can you recommend something for root aphids and gnat-like bugs? Well, preventatively speaking, it's kind of hard, like I was saying, because you could put out something like rove beetles, you could put something out like lacewings, or their larvae, or their adult form, or both. And the problem you'll run into is one of statistics, and that is how many, at what rate, and how frequently do you put out these biocontrols? Because neither of those organisms dig really deep down into the soil, where the root aphid will establish, for example, for aphids, if they're root aphids. If they're not root aphids, and they're not fungus gnats that live in the soil, then you have an easier place, because lacewing larvae and rove beetles stay on the plant and the topsoil respectively. So if you have a regular aphid that doesn't live in the soil, that just kind of lives in the foliage, I would recommend something like lacewing larvae. But it really just depends, because it's a generalist. There are parasitic wasps and flies that you can use as well, but the main disadvantage of that is how many you have to put out per week, and the fact that they're specialists. Which means if you don't have a problem, if you don't have aphids already, and your local area doesn't have aphids, or a suitable host, which has to be aphids, then they're just going to die, or move along. They're going to move somewhere else, and then die if there's nothing for them to parasitize. So I like to recommend generalists for preventative measures, because you have more of a chance of them subsisting on something else, potentially, than the aphid target if it's not there. That's also a concession for most preventative measures in general, because if you have no pests, then you know that your preventative measures are not, your organisms are not going to establish if they're specialists and they need that food, and they're not going to establish that they have no food. So even if you have a beneficial that eats pollen, for example, if you have no pollen, it won't eat and it will die. Zerf1 is saying, would it be beneficial to apply predators early as a cautionary measure? If so, what would you recommend? Absolutely. That's kind of what I'm getting at. You have to sort of make a concession. You have to sort of make a concession that some of your predators aren't going to survive, or some of your predators aren't going to have food if you have no pests and you've crop scouted and you have no pests. But you should put out preventative measures anyways, early as well. You want to establish them as early as possible. But what you use totally depends on what your pests are and what your target is and what your individual location and circumstance is. And that's not me trying to give an answer that's not a real answer. It's just the fact of the matter is that in some places thrips are a bigger problem than in other places. In some places aphids are a huge problem, more so than other places. And different crops depend on or have different pests as their host, or that they host for, rather. So if you have, I would also rather have starving predators than be overrun by pests, and that's the concession that you make. Some people think that that's a waste. Some people would look at that comment with disdain, and they think, oh, well, kind of myopically, they think, well, that's just kind of, that's a waste of money. But it's not. It's insurance, basically. And if you have a high-value crop, a lot of this sort of comes from people who have low-value crops, which are most of them, and maybe they have a very strict budget. So that's the other thing, is that if your budget doesn't allow for it, if you're really struggling, it's not possible sometimes. And I'm not trying to make excuses for people, but that makes sense. Like, if you don't have it, you don't have it. If you're really struggling, then that's just what it is. But people don't consider that. You have to consider the logistics as well. Big Al the Grower says, I'm late to the party. Do you recommend any specific predators for red rice root aphids? I'm only familiar with the rice root aphid. I assume we're talking about the same sort of thing, though. Yeah, so not really specific predators. Like I was getting to before, there are forms of the rice root aphid that will get into the foliage, but you're only controlling the symptoms. You're not really controlling the established population in the rhizosphere. For that, you have to use, like, in my opinion, I think it's good to use like a Beauveria bassiana, some sort of an entomopathogenic fungus that you can just drench spores into. More spores on contact means higher mycosis rate, higher rate, and higher chance of having the insects die. But if you have a really big population, that might not be enough. And that's the other thing, is that rates can be different for different people. There are sort of standard rates that people like to utilize for the recommendations, like salespeople, like different biological companies. And I'm not saying that the rates are fallacious or don't make sense, but for some places you have to use 2 times the amount because you have a big thrips problem. You have to use 2 times the amount because you have a really heavy infestation. It doesn't, just because a biocontrol that you use doesn't work, it does not mean that the bios don't work or that all biocontrols don't work. All it means is that your specific situation didn't work, and if it's not working, you need to find out why. And crop scouting would allow you to assess when that is and why that might be, by looking at patterns in environment, what you apply. Plenty of times people have come to me, they go, my bios didn't work, and I'm like, oh, okay, well, let me see your spray record. Oh, I don't have one. Oh, well, how do I know that you didn't spray, like, flunicimid, or that you didn't spray, like, any sort of mectin that kills everything? You know what I mean? Like, you have to use that context. Mr. Pizza says, the aphids went crazy, the ladybugs can't keep up with them, gonna try to spray something organic. See, that's what I'm saying. And a big part of IPM, a huge part of IPM, is using multiple controls at once, and not have them hurt each other, have it be like a holistic system. Because if you're not doing that, if you don't have that holistic system, and you rely on just one control, pretty soon it's not going to be effective, even for biocontrols. Biocontrols are best for preventative measures anyways. If you have a huge infestation, it will take time. It's not like a chemical agent that people are used to just having a small problem go away or a big problem go away because you're using this potent poison. You can't do that anymore in a lot of places, especially cannabis, which is where a lot of people are asking me contextually where these questions come. But I can't assume that you just mean cannabis. If you do mean cannabis, please just mention that. Otherwise, I'm going to talk in general, which is really helpful because then I can talk about other subjects too that are relevant. H.B. Keene says, how do you establish proper application rates for preventive biocontrol? Good question. The way that I like to do it is I have to evaluate a site. You have to, if you're working in an area, the way that you establish good application rates is, if you've never done biocontrol before, you have to experiment somewhat. I like to use the standard rates of whatever biocontrol company I am buying from. Like if I'm an employee at a cultivation site, whatever plant that is, whatever crop that is. Different places have different recommendation rates, or settings rather. And if there's an aspect of it where I have personal anecdotes that kind of guide me, but every place is different. You have to sort of experiment. I like to go a little heavier than a little lighter because that is more of an assurance that the biocontrol will work, in my experience. But you might find that that's overkill, and you can walk it down, especially if you establish something as well. Hopefully that answers the question. There's a lot of questions that I'm getting that I want to, not a whole lot, but I want to make sure I answer them in the time that I've allotted for myself. Yeah, Big Al's saying that his experience as well, that biocontrols just don't work for him. But like, yeah, sometimes the rates that you're using are bad. Sometimes there might be a compound or a way that you're applying them. And I've had situations where people they get cagey because you don't want to question how somebody is doing, because that might be a really personal insult to them. But it might actually just be the case, and as long as you don't attack the person and you just come at it from a place of positivity and just trying to get to the bottom of what's going on and that kind of a thing, then I think it's great. But a lot of people are very cagey. They're like, "What? You mean I'm the reason why it's not working is I'm not spraying it right, or there's some small aspect of applying some sort of a compound or a biocontrol agent that's not working," and then they get very defensive and that sort of thing. So you have to be careful about that. Yeah, Peter Rand, I'm going to keep doing this. I think it's really important. People are very interested in that. So yeah, you'll see a lot more of these videos. And come with questions, come with cerebral questions or simple questions. Either way, very interested. Sterling the Gardener says, asks, do you think predators stay around the plants outdoors without a greenhouse? Sometimes, if their food is there, absolutely you can establish in the area around you. And if you're like a farmer and you have other farms, you might have, they might have pests that your predators flock to, and they naturalize. Arias, I see a ton of Arias, especially nowadays, or at this season. At this time in the year, tons of people are coming to me, "What's this thing? I've never seen this before." But it's Arias. It's a minute pirate bug, and it feeds on pollen, for example. So it's very possible that some of the plants around you are sustaining that plant. Desert Rose asks, what are some good beneficial biocontrols for soil? Do soil biocontrols, like nematodes or even mycorrhiza, limit the kind of fertilizers you can use in soil? Yeah, so a big part, so this is where I touch on a very important aspect of mycorrhizae. I would be remiss if I didn't mention it. It's not good optics for marketing, but a lot of the literature about mycorrhizal organisms sort of suggests that a lot of them are genotype specific for many different crops, and if you fertilize a lot, if the plant is very well provisioned with nutrients, however you do it, then sometimes the mycorrhizal relationship just doesn't initiate, or initiates weakly. In nature, a lot of mycorrhizal and endophytic relationships occur or establish because the plant is stressed. And the difference between a pathogen infecting a plant and a beneficial, quote unquote, which is a term that we use, right? Beneficials are not like, they're not on some like conscious side of the humans or anything like this. So the difference between like an infection and a relationship with beneficials and pathogens is not really that different a lot of time. And you'll even see that organisms that were pathogens in the past evolve over time to be mutualistic and even symbiotic. And then sometimes the symbiotes, or the symbionts, and they'll become more mutualistic, and sometimes they'll even become parasitic. So that actually happens as well. And if anyone's interested in literature on this, I'm not just talking out of my, I'm just not talking from nowhere. if you've got questions, there's definitely literature that backs this up, and it's a very cool topic that I like to talk about. Hopefully that answered the question. I kind of rambled. Nematodes, Fast Slappy asks, nematodes for what I assume to be rock wool. Oh no, I'm sorry. Nematodes rock for fungus fly. Fungus gnats, yeah. A lot of people have great effect with that. Let's see. I should probably go down to the bottom here. Yeah, temperature. So Doc BD is how I'm going to pronounce your name. Temperatures plays a huge role when applying these types of integrated pest management choices. Yeah, absolutely. I have a video on my YouTube channel, Zenthanol, where I go over the life table and why that's so important to know about. It's sort of dense, and not a whole lot of people know about it, so I'm not trying to gaslight anyone like, oh, if you don't know about the life table, like, you're an idiot. It's not about that. It's esoteric information that not a lot of people think about. Most people don't care about bugs in general, so like I don't expect people to like know all this sort of thing. All of these sorts of esoterica. But temperature will play a huge factor in whether certain beneficials are more or less effective, because it will shorten the pest lifespan, which means that they'll reproduce faster. Thrips are a great example, and in my video I mentioned that as well. Some beneficials just do a lot worse, not because they're hurt by the temperature going up necessarily, but because their prey is more effective. Or reproduces faster, then maybe they can affect change at a standard population rate or whatever. But sometimes it's the reverse, where if you're in the right temperature gradient, then the beneficial has the advantage, and the pest is not. So it really just depends on what your circumstance is, but temperature is a huge factor. Like thrips at like 12 to 15 degrees. Well, western flower thrips at like 12 to 15 Celsius. In one report I was talking about, in my, I have a pest primer video regarding western flower thrips, and I go over how like a simple change in like 2 degrees Celsius shortens the life table, the entire life cycle of western flower thrips by like 2 weeks, And if you're in optimal conditions, it's like a few days. Less than a week sometimes, I think, if I remember correctly. So check out that video if you're interested in an example of exactly what Doc BD is talking about. Let's see, what else do we have? I'm in class and can't hear this. I'll check it out later. That's my point. I don't want people to miss out on something simply because they're like in a position where they can't. I mean, it's Monday. It's currently 1:20 where I am in San Diego. If you don't know, I'm in San Diego. So if you're in the East Coast or if you're here, it's like, it's work time. It's Monday. Like, I understand that totally. I know what that's like. I never know how to pronounce your name, but Ace Binsex, please let me know if that's how you want to be called, because I'm sure you're going to make a lot of really cool comments. You said, I'm sure you've heard about this study that climate change may spur insect damage on crops as they reproduce more. Some people get confused with prior literature on insect decline. How do I clarify this? Super great question. In fact, I was just working with a consultant from Holland, and a big part of our conversation regarded the climate changing and how you have to consider cultivars that are more heat tolerant. Like that was a central tenet to what he was talking about, because we were discussing for a crop what plants to get, what cultivars to trial next, and things like that at this place where I work with. And like it's becoming apparent that the climate's not going to get cooler; it's going to get hotter. And I track their environmental data, and that environmental data shows that that's the case. So how should you clarify that? I would say that the kind of insect decline that we're seeing. So native organisms aren't necessarily pests, and what I mean by that is like the amount of organisms that are pest organisms of crops is big, but they're usually pests because they reproduce a lot, and they're non-native exotics that have no natural predators. Those are two big reasons, and maybe they're very hardy, and maybe they have an ability to adapt rapidly. So those four attributes are kind of very commonly shared among pest organisms. That's what makes them pests, right? The organisms that are declining are not like that. So what we're really seeing is pest organisms that are incredibly great at adapting to change. Those ones are reproducing like mad, and they're going to get even better they're going to reproduce shorter and have much larger populations in a hot temperature than like other organisms like dragonflies and other sorts of things, which will be beneficially affected, but they're not living in a greenhouse. They're not living on crops mostly. They aren't staying there. They're like flying around, getting hit by people's windshields and things like that. And they might be organisms that don't do great in hot weather, or they might be organisms that are solitary, or don't feed on those crops, or they might have a smaller range of food, and those are the ones that are endangered. Those are the ones that are on the decline, not the pest organisms. Those ones are hyper adaptive. Hopefully that makes sense. High succession due to no natural enemy. Absolutely. I have a video on thrips, the invasion biology about thrips. You could check that out by Morse. A research report that really dives into why thrips are so successful at moving between cultivation sites and establishing and things like that. And that's a big part of it. Good point. So I think I'm actually going to wrap up. I was only expecting to do this for like 30 minutes or something like that. Oh, and I just see, this is what I'm talking about. I didn't really want a whole bunch of audio to go through. So anyways, I'm going to catch you all later. I might even have a live maybe in a couple of hours or something. Let me know. Think of some questions. Feel free to ask me some questions. I might put them up on live, and then I'm going to put this up on YouTube. So if you're interested, Zenthanol, Zenthanol, Zenthanol. I talk about it on my Instagram, so just check it out. This is where this video is going to be, and other videos like it will be there, and you can check out the question and answer video that I just made, and all the other reference videos that I have. So, have a good one.